You're listening to Fast Facts Perio Edition. And now, here's your host, Katrina Sanders.
Hello, and welcome to Fast Facts Perio Edition. This week, we are looking at a preprint. Preprints are articles that have been established by research experts. However, this preprint is still going through the peer review certification process. Sometimes preprints are put together as a means of encouraging discussion, commenting, and looking at essentially to other scientists to gather some data around possible errors or reported information that other individuals within the science or medical community might be publishing. So this is still going through peer review, but it has been published because of how progressive this data is. So this research study looks at the role that periodontitis plays in neuroinflammation in the brain. Okay, so let's take this a step back here. This particular research study looks at one of our favorite periopathogens, and that is a good old Aggregatibacter actinomycetum comitans, or AA. Now, when we look at concentrations of AA, we know that this is quite a pathogenic bacteria, although we actually have seen it in concentrations in the oral cavity of individuals who otherwise have a healthy mouth. So this is where we start to see some interesting pieces. Does inflammation in the oral cavity alone create systemic problems, or in the findings that we're noting here in this research study, is it the presence of the bacteria which is elevating complications of systemic disease? So in this particular research study, we look at the brain stems of mice that have periodontal disease. And what happened in this research study was they took high levels of Aggregatibacter actinomycetum comitans, and they essentially wanted to evaluate what happens when the byproducts of AA are able to cross that blood-brain barrier. We were specifically looking at this component called extracellular vesicles. And yes, we did need to learn about this in hygiene school. We needed to know this in order to pass our boards. I know that blows your mind. Extracellular vesicles are particles that are naturally released from almost all different types of cells. These vesicles are released, but they cannot replicate. And that's really important because these extracellular vesicles that get released from our cells are going to hold inside of them proteins, nucleic acids, lipids, metabolites. And it's important to know that these extracellular vesicles can also be released by bacteria. So these extracellular vesicles, these little byproducts or biomarkers, now we're starting to study, because we're starting to recognize that the presence of extracellular vesicles from things like viruses, funguses, bacteria, that they actually can create problems down the road. So we've started to look at what happens when AA releases these extracellular vesicles. And what they found was when these extracellular vesicles are released, they are able to readily cross that blood-brain barrier, that they've found that these EVs, or extracellular vesicles, can actually create major challenges inside of our neurosystem. First, the extracellular vesicles of AA change the action potential of our neurons. And that's really important because as we're looking at our neurotransmitters and we're looking at how the brainstem functions, one of the critical pieces that we look at in dentistry is the trigeminal ganglion, right? When we do local anesthesia, it is that trigeminal nerve, it is the trigeminal ganglion that we are targeting. So first we found that these vesicles that are released by the bacteria AA change the action potential of the neurons in the trigeminal ganglion. Secondly, we found that these extracellular vesicles derived from periopathogenic bacteria are involved in neuroinflammatory disease, neuropathic pain, and other inflammatory symptoms in the brain stem. So now we're beginning to explore, or rather gain insight on the relationships between a patient who has periodontal disease and what that may mean for pain reception, what that may mean for elevated risk of experiencing various types of neuroinflammatory diseases. Now, this is an important concept for us to focus on because when we talk about, for example, neuropathic pain, we do have patients who, for example, are going to experience neuropathies. More specifically, we are looking at our diabetic patients. And then when we talk about neuroinflammatory diseases, we're talking about things like multiple sclerosis, Alzheimer's disease, and Parkinson's disease. So now we're beginning to wonder, when a patient has periodontitis, and if this individual presents with high levels of this periodontopathogen, Agrigentibacter actinomycetum comitans, can we theoretically begin to say that the byproducts or these extracellular vesicles that are released by this bacteria can actually influence or begin to exacerbate neuropathic pain and accelerate the presence of neuroinflammatory diseases? As always, when we look at how this conversation happens with patients, this really becomes, first and foremost, an opportunity to continue educating our patients on what it is that we understand about the oral and systemic disease link, and that interdependent link becomes critical. This is where we now can gather patient history pieces like, do you have a family history of Parkinson's disease, multiple sclerosis, Alzheimer's disease, anything that is going to affect or impact the brain and spinal cord? When we see family histories of some of these neuroinflammatory diseases, this should be a trigger for us to begin exploring, maybe considering doing some salivary diagnostic testing to identify if this patient does in fact have high levels of AA, which we are now beginning to understand could have an influence on neuroinflammatory conditions. This is where we start to get very clear about not just looking at how these oral pathogens show up and can create the ramifications of periodontal disease, but more specifically, what happens when these pathogens are able to cross the blood-brain barrier and begin to allow for the promotion or secretion of pro-inflammatory cytokines inside of the brain. What happens when inflammation associated with interleukin 6 and tumor necrosis factor alpha are now being able to be housed within the brain? And how does this impact the quality of life of our patients long term? These are the exciting data pieces that, to me, really help transform the value and the critical layers of what it is that we do inside of our clinical care as oral health care practitioners. This has been another episode of Fast Facts, Perio Edition with Katrina Sanders. Please feel free to reach me on Instagram at The Dental Wine Genist or on my website, www.katrinasanders.com. Cheers.